Welcome back, students. Now we will be learning another kind of important inequalities, which is rational inequalities. There are a lot of confusion in students for this, so that is why I will be explaining you this step by step. So let's start. Rational inequalities. Rational inequalities are those inequalities in which both numerator and denominator are polynomial functions in some variable. Okay, so let's see how we can find the solutions. Now, in this again we will take step by step. We will first of all talk about the types of inequalities and how do we find poles and zeros. Then taking number line and plotting these poles and zeros and marking the signs wherein it is positive and where it is negative. Then representing different intervals and finding the complete solution finally. So let's see what is our rational inequality and the types of inequalities. Now here we are taking the function fx. Okay. Now here we can easily see that this is a function fx in the form wherein numerator is some polynomial function in x and denominator is also some polynomial function in x. And p1, p2 belongs to natural numbers, and q1, q2, these are also some natural numbers, and these a1, a2, b1, b2 are fixed numbers. Now I can have four kind of inequalities. Okay, one in which my fx is greater than 0, another in which it is greater than equal to 0, next in which it is less than 0 and less than equal to 0. Now how do we find poles and zeros? Now, zeros means wherever my numerator of fx, rational inequality, becomes equal to 0. Suppose I say I have my numerator as x into x minus 1. Then it would be 0 at x equal to 0 and x equal to 1. So, zeros would be 0 and 1. Similarly, when I talk about poles, poles means where my denominator becomes 0. Now, let's take some illustration. Here we have to find poles and zeros. So you can see that numerator becomes 0 at x equal to minus 1, at x equal to 3 and x equal to 5. And here denominator becomes equal to 0 at x equal to 2 and x equal to 4. So these becomes my zeros. My zeros would be minus 1, 3 and 5, and these become my poles. Let's find for this equation. So we can see that x equal to 0. Here if I put 2 minus 3x equal to 0, x becomes equal to 2 by 3 and x equal to 7. So these represents zeros. And here if I put denominator equal to 0, so I will have x equal to half and x equal to minus 4 as poles. Now how do we locate them on the number line? So we will take only one number line and locate all the zeros and poles of the rational inequality. So let's see this case. So here I have zeros as x equal to minus 1, 3 and 5 and poles as 2 and 4. So I'll take one number line and will represent the poles and zeros. So I will have minus 1, 2, 3, 4 and 5. Let's take in this case again I'll take the number line. So 0. Then we have 2 minus 3x, so this will give me x equal to 2 by 3, then x equal to 7, x equal to half and x equal to minus 4. This is how we have represented zeros and poles. Now, what do we mean by marking signs? How do we mark signs? So, here we have 4 rules for marking signs. Okay. Now, what I am doing is I am taking an example wherein I have this function x raised to the power 4, 2 minus x whole cube, x minus 7 upon 2x minus 10, x plus 4 whole cube. Now, I am taking a number line, okay, and I will locate all the zeros and poles. So, you can easily see that here zeros would be 0, 2 and 7 and poles would be 5 and minus 4. So, let us plot all of them on the number line. So, here I have all the zeros and poles on the number line. Now, what we will do is, we will take the rightmost zero or pole. So, here we can see that rightmost I had 0 which is 7. Okay. Now, I will check the sign of this whole fx at x which is greater than 7. Okay, so let's see. If I take x greater than 7, suppose I take x equal to 100 and put here, you will see that fx is always negative. This is giving me negative because of 2 minus x. 2 minus 100 would be negative. So in turn whole fx would be negative. So I am writing this sign as negative. Now, very important point. Once you have written in one interval that this is negative, how will I find in the next interval? We will always change the sign. Okay. Now, we can see that next interval is from 5 to 7. Okay. Now, here because we can see that from 7, after 7 it was negative. Now, before 7, from 5 to 7, again I will change the sign. Now, when I will not change the sign, if my pole and 0 is appearing odd number of times, so you can see that this 7 is occurring one number of time, odd number of times. So you will change the sign. Okay, 5 is also occurring one number of time. So this would again change. So I will say it is negative. The reason is because this is following a sinusoidal curve. So positive, negative, positive. But once you say it is 0, so here you can see that x raised to power 4. So this will not affect the sign, right? So this is positive and here also it would remain the positive. Okay, and minus 4, it is 3 number of times present. So again it will be altered. So always remember, this is very important point, students. When you have power even, you don't have to consider it, right? Because in any case it is always positive. So you will not change the sign, right? And if it is coming odd number of times, you will always change the sign. Okay, so first we are plotting the poles and zeros. So it will divide the number line in various intervals and then we will alter the signs accordingly. Now, the fourth step is, suppose this is my function fx. Okay, so I have just written down all the intervals properly. So we can see that here it is positive, positive. Now let's take illustration. Now here I am marking signs for all intervals for the following equation. So here you can quickly see that zeros would be minus 1, 3 and 5 and here it would be 2 and 4 poles. So let me plot them. So minus 1, 2, 3, 4, 5. If I take some number greater than 5, suppose 100. So you can see it is positive. So this is positive. So it would become negative where it will not change the sign at minus 1. Okay. So again positive, negative, positive. Here also positive. This is how we have understood that after 5 my fx is always greater than 0. From 4 to 5 it is negative. From 3 to 4 again positive. Minus 2 to 3 negative. And then before 2 it is always positive. So we have understood the signs of fx function. Now if I just mark sign for this case, so let us do. I'll have 0. Then I will have 2 by 3. Then I will take 7, then I will have half and minus 4. Okay. So after 7, you can see that it is negative because of 2 minus 3x. Okay. It will always be negative. Fx is negative. Okay. So fx is negative here. Okay. At 7 what is happening? At 7 it is 0. It is equal to 0. Okay. Then 2 by 3 to 7, now it will change its sign, so it becomes positive. It will always change. It will not change at 0. So positive, negative, positive, again positive here and then negative. Okay, because 0 is occurring even number of times. Now, how do we represent intervals? This is important. So there are 4 ways. If I am saying that I have to represent A and B and I don't have to include A and B. The reason is because fx is either greater than 0, less than 0. Equality sign is not there. In that case, we represent it by this brackets, okay, round brackets. And if I am saying that it is including A, I will be using rectangular bracket. If it is including B, I will be using rectangular bracket after B. If it is including both, we will be taking rectangular brackets for both A and B. Let's see how do we write the combined solution. Again, I have 4 cases. Suppose I say fx greater than 0. So we have already understood that how we mark the signs, right? Now, I just have to take the union of those portions which are positive. So this is positive and this is positive. So I'll start from the leftmost. minus 4 comma 0, because it is not fx greater than equal to 0, so I will not be using rectangular bracket. So we can do like this, minus 4 comma 0. Okay, you can see that at 0, again after 0 also positive, so minus 4 comma 2 and union 5 comma 7. So this is my final answer. Now, if I take the second case wherein fx is greater than equal to 0, yes, now we have to understand that fx is greater than equal to 0 will include zeros also, because definitely poles will never be included. Now, this is very important. Never include poles, because if I will include poles, that means I am saying that it is becoming infinity. Infinity is not any number, right? But yes, we will be including the zeros also. So I will take minus 4 this region and this region, and what are my poles? You can see that yes, 2 is a 0, I'll see the zeros, and 7 is also a 0. And these are my zeros, and minus 4 and 5 are poles. Okay, these are my poles. So how I write my answer? I'll start from minus 4 to 0. So minus 4 to 2, yes, I will be including 2 now. Union 5 comma 7. So I will be including 7 also. So rectangular brackets near 2 and 7. So this is how we write the final answer. Let's take the next case where fx is less than 0. Okay. So we don't have to include zeros and poles here. So very simple. Just see wherein I am having negative. So this is the region of negative. Okay. This is the negative and this is the negative. Okay. Okay, so negative regions would be, here I am having, this is my minus 4, 0, 2, 5 and 7. Okay, the solution set would be, I will be starting from minus infinity to minus 4. Union, now you can easily see that 5, between 2 and 5 it becomes negative. Okay, and then after 7, so 7 comma infinity. So this will give me the final answer. Okay, let's take the last case wherein we have fx less than equal to 0. Now here definitely again I will be including the zeros also. So I have this region, but I will be including, and this region also, but I will be including the zeros also. So what are my zeros? I have 2, 7, okay, and 0. Okay, I'll start from minus infinity to minus 4, but I will not be including any one of them. Then 2 to 5, so I will be including 2, but not 5. Then 7 comma infinity, so I will be including 7. So this will represent my solution set. Now, let's write the complete solution for this equation. So first of all, I'll mark down the zeros and poles. Suppose I have this as less than 0. So I'll mark 0, 2 by 3, half, 7 and minus 4. Okay. For less than 0, after 7 you can see it is negative. So positive, negative. Okay. Positive, positive here and negative here. Okay. Now, to write the complete solution, I'll take this region and this region. So minus infinity to minus 4, union 2 by 3 to minus half, union 7 comma infinity. This will give me the complete solution. If you have any doubts in this topic, you can post your doubt for free at askIITians.com. For this, you have to log in www.askIITians.com. and then you have to move to discussion board. Now, once you move to discussion board, on the right hand side you can see Ask Experts column. Now over here you have to select a category. Once you select a proper category, then you can post your question over here, and you can also attach an image. We here, experts at Ask IITians, will solve your question within 48 hours. So students, this was all in rational inequalities. I hope now there will not be any confusion. You will be able to get this solution very easily. Now comes how this particular part can be used in other topics like quadratic equations and functions. So for this, stay tuned with me for the next part. Have a nice day. Thank you.